Welcome, everyone. Today we're going to take a look at some Chapter 4 application problems, or we're going to do something fun. I got a project, so it's going to be an option, right? There's nothing like hybrid education to give us options, so we're going to have an option here. One thing you can do is if you look on the right side of my screen right now, you'll see that I have an application problem, and this whole lesson, let me make this. There we go. It's awake now. This whole lesson as we go through is working on using trigonometry to solve mathematical and real world problems. And we'll also get into this directional bearing, what that means, what it does, and etc. Okay, so that's what this lesson's all about. Now, I've actually recorded a whole lesson for this. So if you kind of want to go through and maybe you're thinking, I don't understand how the application of trigonometry really works, this lesson would be great to go to YouTube and watch in its entirety. Just watch me walk through all of this. Now, why do I say you'd be watching a recording? Because we have a second option, and I've got to be two places at once. So I've recorded different videos, so you can, depending on what you choose to do, you will have access to some education. So anyways, like I said, I have this already recorded on your Google Classroom. So where would you go to get that? If you're in your Google Classroom, I'll just go from scratch. You would click this classwork title right there, go down to Chapter 4, and this Chapter 4 applications. When you open up this document, it'll give you all your instructions, basically for if you choose to continue doing what I would call like more of a normal lesson, going through and watching me teach with the math problems already given to you. So you can go from here, click on this YouTube applications playlist, and this will open up this very first video that I'm referring to that teaches you how to do this lesson if you go there. Now, what else could you do is you can try to do this project. Now, I'm going to link this graph right here. I guess I need to go ahead and link it. I don't think I've done so. Let's go over here, and I wish I could do it like a 3A here. Let's go. It's gonna say I'll do optional Desmos project. What I'm gonna do here is link this graph that I'm about to walk you through. So if I didn't provide enough clarity, whoops, did it work? No, I think I need to press enter. Let's try this again one more time. Link, and we'll put that on there. Bam. Okay, so if you click that link right there, you'll get taken to this document I'm about to walk through here. So to provide more clarity, if you want to go through and learn more applications, you can do so, and you're going to have a requirement of turning in these DOLs. There's 6 DOLs that you'll walk through if you choose to do these application problems today, and you'll learn about bearing and things like that. Okay, and so like I said, there's 6 DOLs. This would be the very last one. If you choose to do that lesson, that's fine. Or you have an option. If you feel like, hey, I understand how trigonometry works, I'm ready to hear about this option. Well, here's what I know about today, 2021, and the future is we rely more and more on technology. Specifically, programming is something that is a way of the future. And so Desmos, you've heard me talk about it a lot, and I've shared so much. Why I love it is you can actually program in equations and save them and share them, as I've done with you many times this year. Today's your turn. So let me start off with a little recap of our trigonometry. Okay, so I'm going to start with, before I even start trigonometry, I'm going to start with just a basic triangle. We know a relationship called the Pythagorean Theorem. And that theorem looks something like this, where we have a squared plus b squared, and that equals c squared. Now, as it concerns right triangle trigonometry, as we've walked through, I've given you examples. Let me get something on here real quick so you can see, where I said, hey, in the case of a right triangle, we can look at it as if you put your angle here, this theta that we've usually been solving for, on the x-axis or at the origin, if you will. We call that standard position. You could have a right triangle where your A could represent x, your B could represent y, and your C would become the hypotenuse. And we worked with that relationship. So the Pythagorean theorem, where we're setting that A is the X value, B is the Y value, and C has become the hypotenuse. Now I want to do a little math here. What if I divided all three of these by h squared? So one way of simplifying an equation is you divide everything. So like it's kind of like multiplication. If you're going to multiply one side, you have to distribute it. Division works the same way. You need to distribute here. So what if I divided everything? It would look like this. Let me get some more space. An x squared divided by an h squared and a y squared divided by an h squared. And that would now equal an h squared divided by an h squared. Whoops, h squared divided by an h squared. Now what does that have to do with anything? Well, h squared divided by h squared is simply put 1. So I'm going to go ahead and delete this h squared divided by h squared because now I know it's equal to 1. Now let's make another observation. X divided by h. I gave you some trigonometric ratios that's based off of an angle in standard position, and that's x over h would be cosine. Well, that means x squared divided by h squared would be equal to cosine squared, theta. Okay, now let's see here. We have a y squared divided by an h squared. Now y divided by h is sine theta, so y squared divided by h squared would be sine squared theta. And of course, this would equal 1. And so we're going to learn that this is called the Pythagorean Identity. We'll learn this in the coming weeks after spring break. But what I want you to know now is this relationship is just the same as the Pythagorean theorem. There's nothing that's really changed. I started with a squared plus b squared equals c squared. We substituted letters depending on how our visual looked. And so we had x squared plus y squared equals an h squared. This again, Pythagoreans for any right triangle. We divided each side by, or divided every value by h squared. And I ended up saying, okay, that's cosine squared plus sine squared equals 1. Now, how does that play out? Okay, so come down here and I'm going to show you the math. What I'm going to do now is I'm going to shift some things up. I have this same relationship without the equals to, and we're going to let Desmos solve this. And I have A. I just typed in an A for angle, okay, because I want to be able to move around the angle. And what you're going to see is depending on the angle, the x value will be solved by taking the cosine of that angle, and the y value will be solved by taking the sine of that angle, because cosine's x and sine is y. And what we could do from there is if we wanted to find the hypotenuse, we do the Pythagorean theorem. And so that's what I have here, the square root of x squared plus y squared. So solving for the hypotenuse here, you take the square root of both sides. So the hypotenuse would equal the square root of x squared plus y squared. And so that's what I have here. So let me just show you. As the angle changes, what you would see, oh, let me turn on this point here. I also have a point. Where'd it go? All right. So I'm going to turn this point on. What I have this point representing is the cosine and the sine. And so you'll see as the angle changes, you will see that dot move all the way around. Now you might notice that if you're looking at the units, it's hitting 1 all the way around. Let me stretch this way. And you will see the shape of it, if I have it stretched perfectly right, is a circle. It appears to be a circle. And so what I have now going is you can see the right triangle at work and that little red point representing a circle. So what would be the equation of a circle? Well, I could come through here and say, well, if my hypotenuse, if you've been watching, that hypotenuse down there is always 1. If I just come up here and put in a 1, watch what's going to happen. I'm going to say that hypotenuse happens to be 1. So instead of doing this, I'm going to say the value we're solving here, h solve. Look what happens. I get a circle. And so no matter where I am or what my angle is, you'll see that it's hitting along this circle. It's a circle, unit 1. Now, it doesn't appear to be a perfect circle just because my screen is not the right stretch the right amount. That's a little bit better. So you can see the radius is 1 on this. It's going up 1, down 1, right 1, left 1. The radius is 1 all the way around. And this A again is my angle going around from 0 to 360. And so that's a little connection between right triangle trigonometry and the unit circle. Now, as the days went on, we started talking about the graphs. Let's see here. I'm going to scroll this down. Y equals cosine. X. And I'm going to change my mode. So hang on 1 second. I'm going to turn this off. And I'm going to change my mode to radians. And let's get this. I'm going to turn cosine green here. And I'll give you a y equals sine graph. And that's in purple. And we started talking about the graphs looking like waves. And I made a calculator where I connected the unit circle to the graphs, so how the values can be solved. Your task for today is I want you to create a calculator. Now, I've created one in complete form. And if you go to unit circle and graphs, that I do not expect you to do yours just like mine. Honestly, though I might be a math teacher by day, by night, I'm a Desmos programmer, and I will know if you try to just go through here and copy my stuff because of all the little adjustments. I made a whole lot of adjustments to make my graph look the way I want to. I'll know if you try to copy mine. You have 1 minute before the beginning of class. Sorry about that. But what I want you to do is try to get a calculator created where you can track how these values connect one to the other. Now, I don't expect you to be able to figure out how to do all these labelings, but one thing I'm going to show you to get you started is what I had over here. The most important thing for you to know is here's your equation for a circle. Now, honestly, for the unit circle, I'm okay if you just leave this as a 1 because it's supposed to be the hypotenuse squared or the radius squared. So you could leave it as 1 squared. I know 1 squared is 1. I'm aware of that, but I'm going to just leave it here so you can see that value. I'm okay if you use this as your equation. That'll generate your unit circle. I'm also expecting every single person who chooses to do the project to have a cosine and sine graph. These are required though. So these are what you see on my screen right now. Your task for today is using these 3 as a starting point, is to create something like this unit circle where it connects an angle with the graphs as they move along. That's your task for today. Now, you don't have to get into everything I've done, but there's just some ideas of what to work from. Again, I would not consider going there. You'd hate to do a whole lot of work and just cheat on a few things and you get 0 credit for it. Don't go there. I'm not expecting you to produce something like I produced. I want you to start with something basic and then just come up with a relationship. I want you to play around. Some little helpful hints I'm going to give you for Desmos is one, if you want to restrict a graph. So let's just say I want to do a flat line at the value of 4. I would type in, just as a reminder, y equals 4. Y equals 4 is a flat constant graph. There's no slope to that. Remember the equation y equals mx plus b. So slope is your m. On our problem, the slope is 0. B is 4. That's what creates a flat line, just to give you full details. And I also want to show you, in case you want to restrict a graph, how you do that in Desmos. And how you do it is you use the squirrely brackets. That's shift bracket. It's just to the right of the letter P on your keyboard. And you can tell it how far left from some domain value. You're giving it domain. You can do range, but I'm going to restrict based off domain. Let's say I wanted to graph from 0 to 5. What happens, I'm restricting the domain here, is the value would start at 0 and it would go on till 5. Now, I didn't put an equal to sign, so technically, yeah, there it is. It should be an open circle at 5 because I didn't hit an equal to sign. So I'm giving you some ideas here because that might help when you graph this of how far you want to show this green and purple graph and so on. I used equations very similar to this to connect my values so that I can show as the angle changes what's happening over here. My graph got slow. Let me press play here. Whoa, way too fast. Way too fast. Let me go to speed and I'm going to slow it down. Okay. Still way too fast. I don't know why that's going so fast. Oh, it's because I changed it to radians. I forgot. Remember how I went over here to my settings and I changed it to radians? Since I changed this to radians, I'm going to change my angle from 0 to 360 to 0 to 2 pi. So just like that. And we are going to change it. This, I'll just go by 0.1. Okay, now there we go. So as this point changes, you might remember I had a flat line connecting these graphs. And so there's your instructions on how to get started. I'm expecting you to stay in the Zoom if you want to do the project and work together. So that means I will not be sharing my screen, but you will be working together, communicating together, and at different times, maybe even sharing your screen. It's cheating to take my equations, but it's not cheating for you to be working together, showing one another your work and what you're able to come up with. I'm expecting a team effort here. So it's like one class grade. Reminder, one last thing. When you're done, make sure you hit that save button. You'll get a unique URL right there. You can copy that and paste it to me.